Welcome to Food and Math TV, where we solve, we learn, and we try. I welcome you guys to this class, and my name is Adu Samson. I will be taking you guys through the course MTS 1-1 with the title Introductive Mathematics. Now, MTS 1-1 is a part 1 mathematics. That is the first mathematics you guys will be doing in part 1, I mean the 100 level, and you guys will be introduced to these 6 topics in this MTS 101. So the course contents or the course outline are sectioned into 6 parts. So the first part, which is section A, we talk about set theorem. Section B, we talk about real numbers and mathematical induction. The C section, we talk about sequence and series. After that, we move to quadratic equations and polynomial. Then after that, we move to binomial theorem and expansion. And the last part you're going to talk about cyclical measures and trigonometry. Now let me tell you, this channel has break all these sections into videos in which you can watch, you can learn and try. And I can assure you A's in this course if you go through these video sections one after the other. Now we'll be starting with section 1, which is the section A, with set theory. We'll be starting with the set theory, where we'll be knowing what set is all about, what are the theorems used in set, what are the biggest rules, how do we solve questions involving set. So let's get started. Now, set theory. Now, as I've said, we'll be starting with set theory. Now, we have to break this down one after the other. What do we understand by set? We understand that theorems are just laid down principles that we follow. But what is set itself? Set is the collection of well-defined objects elements or items. That is what set is. Collection of well-defined or well-related. Yes, we can use that. Well-defined or well-related. What do we mean by well-defined or well-related? When we say that well-defined, that is things having the same characteristics, things that belongs to the same family. For instance, 100 level student is a set, 200 level student is a set. Why do I call them a set? Because for you to be an 100 level student, some characteristics you can call you a part 1 student. Let's take an instance of a mathematical instrument, a mathematical set. The whole instrument itself is what? A set, because it contains things that whenever you see this, you know that this thing belongs to a mathematical set. You see in a protractor, you see in a divider, you know that all these are contained in a mathematical instrument. So that is what we call a set. Now there are basic things you have to understand about a set. A set is denoted by a capital letter. Note that. Set is denoted by a capital letter. Now, what do I mean by set is denoted by a capital letter? That means that if you want to say set A, you are going to use a capital letter. Set A. Set B. You use a capital letter to denote a set. Another attribute of a set is that the element contained, or let's say the items contained in a set, is called a member or the element of a set. For instance, if I have set A to B, another thing is that a set is enclosed in a curly bracket. Now this is curly bracket. Now this is, let's say you have set A containing 2, 4, 6, 8, 10, 12. Now, as I said, a set is denoted by a capital letter, and the elements, these are elements, 2, 4, 6, 8, 10, and 12 are elements of set what? Set A. And they are all enclosed in a curly bracket. That is what a set is. You can see that 2, 4, 6 has a particular pattern in which they move. We can call this a sequence of number which belong to set A. Now, we have other ways in which we represent sets, representations of sets, or how do we denote sets? Now, that is the next thing. After understanding, don't forget that say that set is a collection of well-related or well-defined objects, items, or elements. And I told you that a set is denoted by a capital letter, and items in a set is called a member or element. So these are called member of set A. You can call them member or you call them elements of set A. Now let's move to the next thing. We'll talk about how do we represent set, representations of sets. Representation of sets of a set. The first one is listing method. Some may call it roasting method. What you have to know is that listing method is just a way of let me give an example. When commas separate the element of a set, when you use comma, it will be different like this. This is the listing method. You can see this is 1, this is 2. The 1, 2 has comma within them. So this is what we call a listing method. Another method is called set builder notation. Set builders notation. Now, in this set builder notation, you will not be given the exact element of that set. You would have to read a statement or interpret a mathematical statement to get or to generate the element of a set. What do I mean by that? For instance, if you are given that x is such that x is a prime number, let's say prime factor of 12. You can see the elements of what says A is not given, but it is given in a mathematical statement. X is such that x is what? Prime factors of 12. Now, you are now to what are the prime factors of 12? Prime factors of 12, yes, that is 2, great, 3, what again? That's all. These are the prime factors of 12. That means that I can easily get the element of my set by what? By interpreting this statement. Another way can be given inequality sign, that 1 is less than or equals to x and x is less than or equals to 9. Now this is another set what? Building notation. Set builder notation. You can see that A, you are not giving the actual elements in set A. You are giving in what? A mathematical proportion, a mathematical statement. So I have to read this before I can now interpret what? The element of set A. Now, I have 1 is less than or equals to x and x is less than or equals to 9. That implies that the element of A ranges from 1 to 9. That is what we mean by a set builder notation. Good. I hope you are getting it. 3, 4, dot, dot, dot. The dot should be just 3. Then I have that. Now, another way you can also represent set is by using a Venn diagram. The third way is what? Using a Venn diagram. That's another way of representing a set. You can represent a set using a Venn diagram. Yes. The third one is what? Using a Venn diagram. That's another way in which you can represent what? a set. So a Venn diagram is just when you have a rectangular shape containing different cycles in it, something like this. When you have cases like this, we call this a Venn diagram. This is another way we can what represent a set. Do you get that now? Don't forget that representation of set are those three. We talk about the listing method, we talked about the set builder notation, and the third one is using a Venn diagram. Now, having known this, don't forget we talk about theorems. So I'm going to talk about those theorems when we actually want to move towards Venn diagram. Now, then we are moving to is the types of set. I will list down some types of set, then I will interpret them and explain them one after the other. The first one is a universal set. We have what we call a subset. We have what we call an empty set. Empty set. Or you call it a null set. The fourth, we have what we call a disjoint set. A disjoint set. A disjoint set is, yes, a disjoint set. We have what we call a power set. A power set. A power set. So let's just talk about these ones for now. The types of set: universal set, subset, an empty set, a disjoint set, and a power set. Now let's take them one after the other. What do we mean by a universal set? A universal set. A universal set. What is universal set? A universal set, I can call it a mother set. Yes. What do I mean by a mother set? Calling a universal set a mother set means that it is a set that contains all elements in its subset. I will explain what a subset is. But this universal set contains all other elements that can be contained in its subset. And it is denoted by this symbol or this. When you see this and this, we are talking about what? A universal set. Now, subset. Subset is just a fractional set obtained. I can call it a second set obtained from the universal set. Obtained from the what? Universal set. I'm going to give more examples, you get what I'm saying. Let's take for instance, you have, let's take an instance. Let's take an instance that you have a universal set defined as 1, 2, 3, 4, 5. And you have A to be a subset of the universal set. That means that a subset of universal set is a set that contains a fractional element of what? The universal set. So this could just be 3, 4, and 5. Having 6 here will make A not a subset of what? The universal set, because the universal set contains only 1 to 5. Do you get what I'm saying now? So this is what we call a universal set, and this is what we call a subset. Universal set, types of set, the universal set, and the subset. Universal set is the mother set that contains all elements that are contained in its subset. While a subset is a fractional set obtained from the what? Universal set. That means that all elements that belongs to the subset are contained in the universal set. We can also have a subset from this, we call it B, which will be 1, 4, 1 and 4. Why is B a subset of universal set? Because 1 and 4, which are the elements of B, are contained in the universal set. Now, another type of set we want to talk about is finite and infinite sets. Finite and infinite sets. Now let me just differentiate that. The third one, if I move to the next one, finite. Finite sets and infinite sets. Let's take them one after the other and give example. Finite and what? Infinite. Now, what do we mean by a finite set? Or a finite set? Or a finite? I don't know. But a finite set is a set in which the elements of the set are either countable or the element terminates. That is, we know the end element of that set. That's what we call a finite set. For instance, a finite set. A finite set. A set whose element, don't forget that elements are the set contained in a set, right? The members of a set. When it terminates or it has end, or we can say it is countable, then we call that what? A finite set. For instance, let's say we have a set A and it contains 1, 2, 3, dot, 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 and you see 20 there. This is what we call a finite set. This is telling you that A ranges from 1, 2, 3, 4, 5 up to 20. This is a finite set. Why in the other round, an infinite set is a set whose member does not terminate or ends. Infinite set. Infinite set. So infinite set, let's say we have set A, just be 1, 2, 3, dot, dot, dot. Can you see this? We don't know the end of what? This, because this is a counting number, and counting number does not terminate. That is what we call an infinite set. It ends with these 3 dots, denoting that it continues without end. Did you get what I'm saying now? Great. Now, another type of set we want to move to is what we call an empty set or a null set. Empty set or a null set. What do we mean by an empty set or a null set? Now, from its word, empty, empty set, empty set or a null set, empty set or a null set. Now, when we mean an empty set or a null set, means a set that contains no element. It has no element. It has no element. It's not that its element is 0. No. It has no element and it is denoted by this symbol. Just write a curly bracket or you use this. Element that has no member in it or that contains no member. We call that an empty set or a null set. Now, another type of set is a power set. A power set. A power set. Now, what do we mean by a power set? A power set is a set that contains all possible subsets. It contains what? All possible subsets of a set. All the possible subsets that a set can have is called what? A power set, and it is obtained by this formula, 2 raised power n. Now, what does n means? Where n equals number of elements. It means numbers of elements in a set. That is what this n means. Now let's take an example and draw a power set. I said a power set is what? A set that contains all possible what? Subsets of a set. Either proper or improper. I'm still going there. What do you mean by a proper subset and an improper subset? I will explain that. Now, let's give an example of what a power set is all about. A power set. A power set. Now, let's assume we have a set A which contains 2, 3, 4, and 5. That means that NA. You know, I told you that N means the numbers of elements in what? Now, when you see NA, it means the numbers of elements in A, which is 1, 2, 3, 4. Now, the power set A. Power set A. Let's assume we want to find that is what? 2 raised power what? N, right? Which is 2 raised power 4. Which is 2 times 2 times 2 times 2, which is what? 16. That means that for this set A, which has 4 what? Element, has 16 possible ways in which you can write this or bring out the subset. Now let's try that. Let's try if we can write out the power set of A. Now let's try. The first thing is that an empty set is a member of a set. Yes, not that. Empty set is what? A member of a set. So now let's list this. So you see how we obtain this 16. Now let's start. What are the elements? Let's start with the single element. We have 2. We have 4. We have 5. Let's speak in twos now. 2, 3. We have 2, 4. We have 2, 5. Are you getting it? I'm picking these two. This. I'm not picking. You have to pick them without repetition. Like for instance, if I pick 2, 3, I can't pick 3, 2 because 2, 3 has already what? Exist. Now we are done with that. Let's move to the next phase, which is what? 3, 4. 3, 5. 4, 5. Now I think let's now pick in threes now. That's 2, 3, 4. 2, 3, 5. 2, 4, 5. Next one, 3, 4, 5. 3, 4, 5. And 2, 3, 4, 5. And the last one will be an empty set. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is what the power set of A. 16. Are we able to achieve that? Did you get that now? Great. Hope you are getting it. So this is how you get the power set. You list out the element individually, you pick in twos without repeating what you've chosen before. 2, 3, 2, 4, 2, 5. That's done. 3, 4, 3, 5, 4, 5. You're done with that. Then you pick in threes. That's how I'm able to achieve this. And then an empty set is a member of what? A power set. And the next thing I want to talk about is type of subset. Yes, we have type of subset. We have a proper subset and an improper subset. A proper subset and improper subset. Proper subset and improper. So a proper subset and improper subset. Now don't forget that I told you that a subset is a fractional what? Is a fractional part of what? The universal set. So a subset can either be proper or improper. Now what do we mean by a proper subset? Now let's start with this. Universal set. 1, 2, to 10. You know, this is a definite word. And you have A. Now A is 1, 2, 4, 5, up to, let's see, up to 9. Now, this A is a proper subset. What do you mean by a proper subset and improper subset? A proper subset will contain a fractional part of the universal set. It won't contain all the members. Like this. Why? If B, this is a proper subset because all these elements are contained here, and it does not contain exact elements in the universal set. But let's assume that B is 1, 2, 3, 4 up to 10. Now it is also a subset of what? The universal set, but it is called an improper subset. Why? Because it contains exactly the same element in its mother set or in its universal set. So this is what we mean by a proper set and improper subset. A proper subset and improper subset. Proper subset will contain a fractional element of the universal set, while an improper will contain exactly the same as its universal set. Now, after knowing this, we also have what we call a disjoint set. I will introduce a disjoint set when we get to operations in set. So the next thing we want to move to is operations in set. We're going to move to what? Operations on set. So the first one we're going to talk about is union of set. Now, what do you mean by union of set? Union of set means, let's say, the union, let me write, the union of set A, the union of set A and set B is a third set. Yes, is a third set. Is a third set containing. Is a third set containing all the elements. Containing all the elements in set A and B together without repetition of common sets. Without repetition of what? Common sets or common element. Without repetition of common elements. Now, and it is denoted, the symbol is denoted by this. This is the symbol for union. When you see the symbol, implies what? The union of a set. So what I write here is that the union of a set A and set B, that means we want to find the union of two sets here. Set A and set B is a third set containing all the elements in set A and set B together. We are going to bring the elements together. But note, without repetitions of common element. That means that if an element belongs to A and also belongs to B, you will not write it more than once. Now, let's pick an example and see examples of what? Union of sets. Union of sets. Examples of what? Union of sets. And don't forget, it's denoted by a U symbol. U symbol. Yes. Okay. Now, example. If A is 2, 4, 5, 7 and set B is 1, 2, 5, 9, 10. Question answer is that find A union B. Now, A union B will be what? Bringing elements in A and B together without repetition of common element. So now let's bring this element together and you can arrange it in ascending order. So 1, 1, we have 2, 2, just pick 2 once. 4, right? 5, 5, you pick it once. 5, 7, 9, and 10. So this is union of what? A and B. What do we just do? We combine elements in A and B together to form a new set. And this new set is denoted by its union, which contains elements here. But what we did on the way is that we did not what? Write, look at 2 is here. 2 belongs to A and B. We write it just once. You won't repeat what? Common element. That's what we mean by union of sets of common element. Now the next one we're moving to is intersection of sets. Intersection of sets. Intersection of sets. Now this is the symbol. This symbol implies intersection. When you see the symbol like N, it implies what? Intersection. Now what is intersection? The the intersection of set A and set B is a third set containing the common elements. It contains what? The common element in both sets. It contains only the what? The common element in both sets. What do I mean? Intersection means the common element in the sets, you bring them out. Example. Now, A is given, you can notice that set A and set B are given in what? Set builder notation form. What did I mean by set builder notation? We have to interpret this statement or this mathematical word proportional statement before we can bring out the element of what? Set A and set B. Now let's do that first before we can now. Our main goal is to find what? A intersection B, but we have to interpret the set first. Now the first one, even number less than 10. What are even number less than 10? Great. 2, 4, 6, 8. You can't write 10 because the set is less than 10. You stop it. Now B is defined by x. You see, x is such that 1 is less than or equals to x and x is less than or equals to 5. Now that means that 1 is less than equals to x. That is 1 to 5, right? 1, 2, 3, 4, 5. Now, what is A intersection B? A intersection B. Intersection means what? Bringing the common elements, right? In both sets. So the common element in both sets will just be what? 2 and 4. Great. That is the intersection of A and B. Now, intersection brings me back to a definition of a type of set which we call a disjoint set. What do I call it? A disjoint set. What do we mean by a disjoint set? Now let me give an example. What do I mean by disjoint set? Let me give an example. Now let's look at this example. And our instruction stick follows that we should find A intersection B. Now, what is A intersection B? If you look at it very well, what is A intersection B? There is nothing common, right? Great. That means their intersection is an empty set. Don't forget this or this. Now, that means that A and B intersection, since A and B intersection is an empty set, we call them a disjoint set. Why? Because their intersection is an empty set. That means a disjoint set, or we can say sets are said to be disjoint if their intersection is an empty set. A disjoint set. A disjoint set. Disjoint set is a set when the intersection between the given set is what? An empty set. Do you get that now? That's what we mean by what? A disjoint set. Now the next thing we want to move to is complement of a set. Complement of a set. Complement of a set. The complement of a set. The complement of a set is a set containing, the members of the universal set. The members of what? Don't forget that the member is still the same as the element of the universal set. the element in of the universal set, but emphasis on what? But not in the subset. But not in the subset. That is the element that we have in the universal set, but that is not in the what? The subset. Now, this complement. Now, the complement of A, that is set A, is written as, you can call it A prime, or you call it A prime or A complement. These are the two symbols we use for representing the complement of a set. So whenever you say you find the complement of a set, what will you just do? You list out the members of the universal set, but not in that subset. Now let's pick an example so that you can understand what I mean by that. Now, example of the complement of a set. Example. Given universal sets, let's say A, B, C up to Z, and you have A as A, E, I, O, U. That's our vowel sound, right? Now the question now said find a complement. Now, don't forget that A complement is just the same as our consonant letter. Why? Because A are what? Vowel sounds, vowel letters. These are our vowel letters. Definitely, A complement are elements. Note, I told you that complement of a set are elements in the universal set, but not in that set, which is the subset, with our consonant letter. Our consonant letter. That's all. You can list it out. So A complement, what are the elements in the universal set but not in the subset? We have B, we have C, we have D, so on. Do you get that now? The last one, which is Z, the consonant letter. No, I already state the consonant letter before writing this. That is the complement of the next part, which is difference and symmetric difference under the operations on set. Difference. So let's take them one after the other. Difference. What do you mean by difference? Now, difference has two symbols. It's either a minus sign or a backward slash. These are the two symbols that we use for what? Denoting difference. Now, what does difference mean? Now, let's say you have A difference B. Or, don't forget that it's still the same as A slash what? B. Now, this just implies elements in A. Let me write this way. Elements in A. Don't forget that difference has two symbols. This and this implies element in A. Elements in A, but not in B. That is what A difference B means. But when you have B difference A, which is same as B slash A, is still the one I was elements in B, as element contained in B, but not in A. So let's pick an example and do this too. Example 1. Example. Let's pick an example. The first one. Okay, example. A. Let's define A. Set A as 1, 2, 4, 5, 6. And B as 2, 4, 7, 9, 10. 2, 4, 7, 9, 10. And the question says that A minus B, or A difference B. Now, to do that, I think that A difference B means elements in A but not in B. So there are two ways in which you can do it. Is that you just write it this way, 1, 2, 4, 5, 6 minus, that is, you subtract it. 2, 4, 7, 9, 10. What I just do is that I take out elements here that are here. So 2, take this off. 4. So do you have any common element? No. That means that A minus B or A difference B are elements in A. These are the elements left in A, but not in B, which is what? 1, 5, and 6. So that is what? A difference B. That's how you find A difference B. Now, the other case, what about if you have B difference A? B difference A. So B difference A will just what? Be what? Elements in B but not in A. So you can also apply this method. So let's do that. Let's do that. So B difference A. So that will be 2, 4, 7, 9, 10. B comes first, right? Minus A. 1, 2, 4, 5, 6. So the first thing, you just take out the common element. There are intersections of this is here. So what element do you have in B left? So that means that B difference A will be element in B but not in A, which are the 7, 9, and 10. So this is B difference A. Do you get that now? Great. Now the next one is symmetric difference. Symmetric difference. Symmetric difference. The next one we're going to talk about is symmetric difference. So symmetric difference also has two symbols. A symbol of phi. You can use phi, or you can use this symbol. These are the symbols that denote or shows what symmetric difference. Now, you have to be very careful here and listen, please. The symmetric difference is very simple too. Now, A symmetric difference B. Now, asymmetric difference B has two formulas. Now, this can be interpreted as A union B difference A intersection B. This, you can use this formula to get the symmetric difference of A and B. Or you use A difference B union B difference A. Either of these will give you the same answer. A symmetric difference B, you can achieve it by finding the union, then take the difference from what? A intersection B. Or you just find A difference B, then you take its union with what? B difference A. So now let's try this. Let's have an example to try what we have on the board. I'm going to use both formulas and see if our results are the same. Example. Given that A is 1, 3, 5, and 7, and you have B to be 2, 3, 7, 9. Now, let's start with the first one. The question has said find A symmetric difference B. Now, which of the approach should we start with? Let's start with the first one. We say that this is very equal to A union B difference A intersection B. Now let's start with what? Finding the union. Now let me clean up the upper part. Find now let's start. A union B. Don't forget, what does union mean? Union means bringing the elements together without repeating common elements, right? Great. Bringing the common element without repeating that. Let's bring it together. 1, 2, 3 is common. You pick it once, right? 5, 7, and 9. Correct. Let's find the intersection. What does intersection mean? Intersection means what? The common elements in both A and B. So what's common to A and B? 3 and 7, right? Correct. 3 and 7. Now let's find the difference. Let's find the difference now. Since we know that symmetric difference says that what? A union B difference or minus A intersection B. So let's do that. Okay, with that, you can just manage this, please. A union B. Okay, let me clean this off. 1, 3, 5, 7. So we'll not clean it off. 2, 3, 7, 9. So A symmetric difference B now will just be, we said A union B divided by, or difference A intersection B. Let's do that now. Now, what is A union B? A union B we have what? 1, 2, 3, 5, 7, 9. Difference. Don't forget that symbol starts for difference, right? Intersection is what? 3 and 7. Right now, let's take that. Let's do that now. I replace that. A difference B will be what? Taking off the element in the union. This take this off and this take this off. So what do we have left in union? That's A 1, 2, 5. So this is A symmetric difference B. Using the union difference, the intersection. Now let's try the other part, which is using what? A. Now applying, we said there are 2 ways in which you can get the symmetric difference. We just finished with the first one, the first method. So let's try the second method. A symmetric difference B. So let's use this approach. A difference B union B difference A. Now this time around, what is A difference B? What is A difference B? Can you do that? Yes. What is A difference? Let's do that together. 3, 5, 7 minus 2, 3, 7, 9. Now, what is, let's take out the common. This is this, and this. So we have what? 1 and 5, right? So what is B difference A? This time around, you're going to do B difference A. Just take out the common element in what? The A and B, which is what? 3 and 7. So what do you have left? If 3 and 7 has gone, we have 2 and 9. Correct. 2 and 9. And we take the union. Because we say that the union of the difference brings the symmetric difference. That means that A symmetric difference B just be the union, bringing these two together. That is 1, 2, 5, 9. Can you see we have what? We are aiming at the same answer as using A union B difference A intersection B. So that is how we can get the difference using both methods. So this will bring us to the end of the class. Thank you very much, and stay tuned